Hello, and welcome to Robotics and Codings for Littles. My name is Jessica Sierra. This is going to be a purely recorded webinar. Apologies to those of you who logged on the other night when we had some technical difficulties, but this is a re-recording of our original webinar. I have the privilege of being on the SDCOE EdTech team. This is the rest of my team here. My director, Alicia Gallegos Butters, coordinators Pam Rabin and Chris Garcia, and our project specialist, Carrie Lane, and then of course myself. The bit.ly is here for this slide if you'd like to follow along or just bookmark it for future reference. Just a quick plug with some upcoming events we have. You can click the link at the top to visit our calendar. This calendar also has any previously recorded and held webinars or sessions and materials that you can access if you've missed out on things or if this is your first time seeing our calendar. A couple things that are coming up quickly. Next week, October 30th, we have Pam and Carrie presenting some AI ready-made slides. So if you're interested in incorporating AI into your classroom but don't know where to start, this will be a great session of some really quick activities that you can plug into everyday lesson just to try out different AI tools and AI topics. On Tuesday, November 5th, we have our Back to Basics series. So we host a series that's all about the Google Suite and just returning to those basic skills. We've had docs in classroom already, and November will be all about Google Slides. On Saturday, November 2nd, I realize this is probably more of an early ed crowd, but just in case you also support middle school or maybe you have middle school children of your own, we have an esports tournament on Saturday, November 2nd that will be playing Rocket League. It's actually full as far as playing teams go, but you're welcome to click to be added to the wait list in case something drops out, or just to get registered and find out about future events. And then lastly, we have on November 14th a session all about accessibility and AI powered access. So, helping students access different content and transforming their educational experiences by using AI tools. Okay, so again, my name is Jessica Sierra. I am an EdTech TOSA for the Innovation Department within EdTech for the San Diego County Office of Ed. And I primarily work at this lovely building, the Linda Vista Innovation Center, which I'll talk more about in upcoming slides. But if you haven't visited us before, our goal at the Linda Vista Innovation Center, or LVIC, is to host lab experiences for students all around San Diego County where they can come and experience different careers and what those careers might entail, like advanced manufacturing, robotics and ICT, 3D printing, design thinking, wind and energy, and also health careers. So we offer a variety of labs at our Linda Vista campus. In this session, I'll be talking about the following things. So, robotics and coding for littles, I'd like to start out with what it looks like because for me, it's really important when I'm approaching a new topic to actually see and get a feel for what it might look like. Also, a little background about why, what's the purpose in coding in early ed, what are some of the benefits? Then what do I teach? So what are some things that topics that you might want to start with? How should you progress through the standards? And how do you integrate that into your academic classroom already? And then lastly, how do you do this? So what are some strategies and some resources that you can use to work through those standards and topics? So at our LVIC campus, my EdTech for Littles lab looks a little bit different than what a traditional classroom might look like. Again, because our goal is really to reinforce and expose them to different career pathways. And so the first thing I like to do when they come to my lab, whether it's coding or our design thinking or podcasting, is talk about uniforms and get them to create something that puts them in the place that they are participating in what could be a future career. So for our coding and robotics lab, we have them create these cute little hats that have coder on one side and engineer on the other side. And throughout the lab, we sort of flip-flop between the different sides, whether we're doing an activity around programming where they might be considered a coder, or whether we're building parts of a robot that may be considered more the engineer side, because robotics and coding are twofold, and so we want them to understand that these are two sides of the same coin, that there are two different fields within this broader industry. And I don't have a good picture of the other side, so I used my own little to model the engineer side here.
Engineer, engineer.
And then the link to that hat file is linked below here. And it's just a sentence strip that we staple them to. So really easy, easy lift. All right, but there are a lot of things in my lab that do look like a traditional classroom, because another goal of mine is to not be the only teacher out there doing robotics and coding. So I really want to show teachers how they can incorporate it into their own classrooms with materials and activities that they already do. And one component is literacy. So we start every lab with a literacy component, and in our robotics lab, we use the book Rosie Revere Engineer. This is part of the Questionnaires series of books. If you've never heard of those, highly recommend checking them out. They're great for engineering, robotics, or just a lot of soft skills like perseverance. Rosie Revere Engineer deals with a lot of like being courageous with your creativity and being willing to share and work through failure. So I've linked that book there as well as our EdTech for Littles book list, which is always growing. So there are books in there around design thinking with some potential activities that could go along with it, and also books around robotics. If there are things that you use that are not on that list, please reach out and share them. I'm constantly building this list with the hope of sharing it broadly and giving teachers that resource. Another component that we use in our robotics lab is movement. So I'm sure I'm preaching to the choir that our littles need to get their wiggles out. So that is one purpose of including movement, but also a lot of activities that we do that have them moving are a great introduction to coding itself and algorithms. Things like dance are just a series of steps, a series of following instructions, which is exactly what coding is, even at its most complex algorithms. It's really just a series of instructions for your machine, for your computer or robot, that you're trying to communicate. And so dance is a great way to introduce the concept of taking steps and following instructions. So we do a lot of that in between our different robotics activities. Hopscotch is another great one if they have the physical balance and movement down and can do some hopscotch outside. You can incorporate numbers. It's another great tool just like dance. And then we also do a code a friend type of activity where we have them code their teacher. So this could be done with peers, but we find that they really love being able to code their teacher. And so in the background there, underneath the kiddos on the floor, you can see there's a taped out grid. And we'll typically put some kind of toy or object on the floor, have a kid choose to place it somewhere, and then have the class direct their teacher and code their teacher to be able to get to the object. And it's a great exercise in being really specific with instructions, because they could tell their teacher, go forward, go left. And then maybe their teacher continues to go forward and doesn't stop. They have to be very specific. Go forward 2 squares, go forward 3 squares, and then turn left and then go forward. So you get the idea, but it helps them get into a place where they're creating very specific instructions before we enter the realm of working with the robot and the coding tools. A couple other videos that we use just to incorporate some movement are some Danny Go videos. So I'm sure as early ed teachers, you're probably familiar with Danny Go. He's got a lot of great little brain break videos where kids can dance and move and just get the wiggles out. But these robot videos are actually pretty good because he's also having them do certain steps and certain moves. So it continues that conversation about coding and following instructions and giving very specific instructions. And they're also just really fun videos that the kids love to watch. Another component we incorporate into robotics is arts and crafts. So it's important to me to include different modalities in our lab so students that are more kinesthetic have an opportunity to experience robotics and coding through that movement. Students that are more artistic get an opportunity to engage with robotics through something like this activity where we have them sort of build their own robot out of different shapes. This is also a great tie to the academics they're learning in class. So usually in TK, they're identifying shapes, they're identifying colors, so we can have those conversations with them about which shapes they're choosing, how they're going to put it together to build what looks like a robot. And as they get older, they start to be introduced to patterns, which is just essentially coding, right? So coding is a lot of patterns, a lot of loops, a lot of repeated steps, repeated things. And so we show them that through pattern building. So we have them build a pattern of shapes, a pattern of colors. We let them get creative and how they want to communicate their pattern while they build their robot. So another fun way for them to take a break from the technology and do something artistic while still really building the language around coding and also the skills around coding. And then lastly, of course, we have our robotic centers. So we have a variety of activities that we do with the robots, and we sort of intermix robot play, robot centers with breaks with art, breaks with movement, and breaks with the books. Okay, as far as robotic devices, these are the two that we chose to go with for our lab for a variety of reasons. These are definitely not the end all be all. As a county office, we can't necessarily recommend certain vendors or certain products. This is just what seemed to work in our lab for the variety of things that we needed to accomplish. But I know probably many of you already have some kind of robot that your district purchased. A lot of the tools and activities that I'll go over in the rest of this session are totally doable with a variety of robots. So they're not device specific to either of these two, but these are two of my favorite that I wanted to share. The M Tiny. We chose because it's just very expressive. I mean, you can see from the picture, it looks like a toy. The TK students especially love to work with this toy or work with this robot, which they see as a toy. But we also like that it has physical coding cards that are pretty durable. They're made out of like a cardboard, but they've held up really well over like hundreds of kids at this point. They also have a variety of sort of complexity that you could use. So those you don't have to use the little green flag starter card. You could totally just do one card at a time. You could just do the movement cards, like you see the blue sort of forward straight arrow. They could just work with those and it's still really impactful. Or as they get better at it, you can increase the complexity with the multipliers. There are parenthetical loops you could use. Um, and also the purple cards are one of my favorite because those are expression cards. So you can get a little SEL lesson in there about feelings and noticing how emotions look. It's hard to tell in this picture, but the eyes on this robot are actually like LCD screens, so it can appear to be mad or crying or happy. So that's just a fun little extra in there. And also the it's controlled by a pen. So it's sort of like Bluetooth, RFID transmitted, and they just tap the pen on the cards they want to use. So it's very easy as far as like their mobility. It's really easy to access. The Kibo is a new robot that we're looking into purchasing for our lab. One thing I like about this is the underside is actually clear, so you're able to see all the inner workings of this robot. So it's a nice level up for like our kinders, our first grade, to start looking at what is inside a robot, talking about the different parts. It's not just this fun toy, they can start to look at components. And also the things that you see on top are modular. You can take those out or you can put extras on, but they're all different sensors. So now we get to include the conversation about how does a robot see? How does a robot hear? How does a robot react by turning on a light? How can we make a robot do that? And then what are the different features or functions of a sensor? What does that mean? They can build this robot to some extent as far as taking the wheels on and off and adding different sensors. So it does add that engineering perspective. And then it also has the block cards, so similar to the M Tiny's coding cards. The Kibo has little block cubes that they scan and they can put in order for what they want to use. So that's also just like a really tactile, easy lift for the little early eds. But like I said, this is not an end all be all. I'm sure many of you have some of these other devices. I know the Bebot is very popular and comes with some really great floor mats. The Go mouse is kind of similar to the Bebot, more of like a maze style, but similar in function. You have Dot and Dash, which is another great tool. The only difference with this one is this you have to operate with an iPad or a tablet, so you would need that extra device in the classroom as well. Whereas Bebot, Mouse, Kibo, and Tiny are all screen-free devices. They're all self-contained in their own device. And then, of course, in the lower right corner here, you also have like Scratch Junior or some coding apps where they're moving into screen coding and using that Blockly coding template. So lots of options out there. I'm sure there are others that I've missed on here. So message being, don't feel like you have to run out and purchase a new robot just to get some of these activities down. There's a lot of ways that you can incorporate things that you already have or things that your district has adopted. Okay, why coding for littles? So I'll move through this part a little quickly because I'm sure if you're here, I'm kind of preaching to the choir on this one. But I do think it's important to include, especially if this is a conversation you're trying to have with your administrators about why this is something you want to do in your class, or perhaps parents that may be hesitant to have their students coding on devices. Um, there's some solid research around why coding is a very good idea for littles. This one, just because we are a career tech sort of building, we have that focus. It is projected to grow as a field 17% over the next 10 years. So by the time our littles are graduating and looking into graduating and going to college, this is still a field that will be booming faster than average for all occupations. Certain realms of coding or computer science have lower expected growth because of things like AI making the process a little simpler, exporting jobs to different countries. But there are plenty of jobs such as software developers, computer scientists that see, in the 10s to 25% growth over the next 10 years. So it's still going to be a solid field, a very well-paying field, and also something they could do locally because we have a lot of tech companies down in San Diego. Okay, I also wanted to include this video of this young man so you can hear from an actual young person how they feel about coding and the benefits of coding. So I'm just going to play about a minute of this.
I'm passionate about coding and development. Over the last several years, coding has taught me a bunch of coding-related skills. I've learned HTML, CSS, PHP, JavaScript, MySQL, Ruby on Rails, Objective-C, Unix, and a bunch of other web server things. It has also given me a few coder-related bad habits, like poor posture. I've also picked up a ton of general computer-related skills. I've learned word processing, design, and database apps. But coding has taught me so much more than coding. I've learned logic, time management, dealing with failure and setback, organization, design, entrepreneurialism, being part of a community, problem solving, creativity, critical thinking, collaboration, communication, and yes, public speaking. This is great, but there's a problem. I haven't learned any of this in school. I've done it all at home with my dad and on my own. I get to code for only about 15 minutes in the morning before school and about only 30 to 60 minutes at night after I've completed all of my homework. See, that's time management. I wish I could learn coding and development in school, but I can't. It's not offered.
Okay, so we're going to break that down
I'm
just a
passionate.
little bit. Some of the things he said that really stood out to me were this long list of academic skills that were related to coding. So things like logic, organization, problem solving, even creativity are sort of those peripheral skills that they'll get just through doing coding activities. Also, the fact that he had a pretty substantial resume, if you will, just from 15 to 45 minutes a day doing coding. Now, this is a crazy outlier, but imagine if we just had 15 to 20 minutes of coding every week for all of our students, the type of levels they could get coding through just that time at school. And then also, of course, that he wish he could learn it in school, but it's not offered. So that has changed a lot. This video is about 10 years old, I think, at this point. But sadly, that's not the case widespread. So there are definitely schools that are incorporating coding, encouraging coding and programming, but there are many schools that still, it's just not a priority. I also like to push that computational thinking is a framework for learning. It's not just a skill or a subject that is completely self-contained. All of these skills are things that they're going to encounter in life and as they continue their journey learning in school. So computational thinking is really just breaking down problems, coming up with solutions, looking at data. And then algorithms is just planning out your steps of what you might do. So definitely we see this in coding, but we also see this in life. And then especially this statistic was what started me on this path for ed tech for littles was that by fourth grade, students have internalized whether or not they're good at STEM. And so we were seeing that a lot of programs for STEM for coding typically start around fourth grade, fifth grade, maybe. Mostly they're in middle school because at that level, students can really kind of wrap their brain around the abstraction of coding. But if this statement is true, which the research is showing that it is, that's too late. So we really want to start doing these things earlier, in different ways that are developmentally appropriate, so students can feel like they're good at STEM. And not every student's going to go into being a coder or a computer programmer, but they can still see it as something that they can be successful at in school and learn some of those peripheral skills, even if that's not something they want to pursue in life. Okay. I also wanted to share this new movement of looking at computer programming as a new 21st century literacy. We all know our generation Alpha is surrounded by technology all the time, whether or not we have it in school. I mean, everybody, parents have cell phones, there are computers around. TVs, AI is kind of everywhere at this point. And so it is becoming something that they're going to need to know. And this group that developed Cal also developed Scratch Junior and also worked on that Kibo robot that I showed a few slides back. So they've developed a whole curriculum approaching coding as if you would approach another language. And so I'm just going to play about a minute of this video from their founder talking about their perspective on coding.
Coding as another language positions the teaching of computer science, the teaching of coding, the teaching of computational thinking as learning a new language, because programming, it's an artificial language. It's a language that computer scientists use to communicate with computers and other technological devices. The same way that we might use English, or I grew up speaking Spanish in Argentina, so I use Spanish. So to communicate with computers, we use programming languages. And in this case, the curriculum is focused on Scratch Junior. However, we want children to be acquiring this wonderful new artificial language of computer science through Scratch Junior at the same time that they are strengthening their own written languages. You know that early childhood is a time where literacy is the most important. This is a time where we really learn how to read and how to write, to communicate ourselves, to express ourselves, to have a voice, and eventually to develop into contributors to our civic society. So, coding as another language brings the two together, brings literacy and brings computer science, so children can be learning both together. Coding as an
Okay, and then one of the things she said is also something that is called out in our California computer science standards is that computer systems are a way of creative expression now. So they have the power to facilitate that creative personal expression. Computers are both the paint and the paintbrush. So they are the finished product that we see, but they are also the tool that we use to create the finished product, which we can see here in Scratch Junior as somebody's creating like an animated little video. So I just wanted to include that. It's not just this technical, very techie topic. It can also be a way for students to express themselves and be creative. All right, so that's the pitch on coding, which also has a lot to do with robotics, but I wanted to include a slide strictly about why robotics is so important in early ed, and it's because of the way coding on a screen is so abstract. If you look at that GIF in the middle, they're putting together these different instructions, these different moves, and they may see a character move around a screen or do some things, or backgrounds change or colors change. But it's so much more powerful to see coding in your physical space, especially for our littles that are learning and developing in that way already. They're kind of learning their place in the world and their spatial recognition, they're learning boundaries, and to experience coding and robotics coding in a way that incorporates robotics, they get to see a physical robot move around a physical space, understand that their instructions from their coding cards make something move in an actual world. And I think that piece is really important in the earlier grades. And then as their brain really understands that, it's easier for them to move into this more abstract coding applications where they're now just seeing it move around a screen or just see certain things that they're designing for a computer. Okay, so getting into what to teach. My first piece of advice is always to incorporate skills you're learning in other subjects and really let coding be the reinforcer of whatever topics you're covering, be it animal habitats or the alphabet or the number line. Teach what you're going to teach and just do it in a way that includes coding. It shouldn't be just coding for coding's sake or robotics for robotics sake. It should all be tied back to what you're already doing. Every robot I've seen comes with some kind of floor mat like you see here. But you can also design your own. It's not that hard to tape off a section of your room if you have tile floor or do some chart paper. The robots I've used move around really well on just plain chart paper. And it's just a matter of, creating a grid for yourself and deciding what you want to put on there. So in this case, it's the alphabet. In other cases, it might be like pictures from a story that you've read and having students use the robot to act out the story. So they're doing some summarizing, doing some recall skills, but also having to do it through coding a robot. So they're also learning the coding skills that way. In this video, this was from our pilot, and this was, they had been studying animal habitats. This was a TK class, and what animals need to survive. They need food, they need water, they need shelter, and how those things look different depending where the animal lives, or what the animal's needs are. And so our M-Tiny robot actually happens to have a floor mat itself that has different food, and it comes with little animal masks that you can put on the robot. And so it was a really perfect fit, but this is doable for whatever robot you have. You may just need to create your own floor mat depending what animals you may be using. So I'm going to play this real quick.
All right, I think we're missing something. What are we missing? Oh, straights?
And so the student has chosen the chicken mask,
All right, let's
and
try
we're
it.
working to create an algorithm, a sequence of coding steps, to be able to get to that corn that we talked about, is what the chicken eats. And so you'll notice in that video, at that point, we weren't totally structured on sequence. We were just focusing on input output. So maybe his sequence was a little out of order, but he still was practicing knowing that animals have to eat a certain food, that chickens didn't eat meat, they ate corn, and then using those coding directions and learning how input and output works for a robot. Some documents you can rely on because as teachers, we always want to go back to standards. So in addition to whatever English or history or math standards you might be working on, if you're looking to see what computer science standards that are appropriate for whatever age you're teaching, California has come out with a K-12 computer science standard document. And what I love about this one is it's actually industry informed. So they worked with teachers, educators, but also included industry professionals and also higher ed instructors for computer science to see what are the skills that colleges are looking for in or colleges are teaching in their computer science classes. What are the skills employers are looking for, and how do we translate that all the way down to the K level, first, second, third, and all the way up? How do we level that up throughout the K-12 system to ensure that our students are prepared for college, prepared for career? What are some things that are age appropriate as they move through the K-12 system? And so you can check that out if you're looking to see like what skills are appropriate, what skills should you be teaching. But also, I love these ISTE standards. And if you're not familiar with ISTE, they're just an organization that comes out with different tech things for education, but they have these standards for technology that apply through K-12, and they're really the soft skills, like being an empowered learner, constructing your own knowledge, um, persevering through failure. So it's some of the soft skills that you may be looking to teach. This is a great document to check out, and they also have standards for teachers if you happen to be in like a teacher coaching role that you could help your teachers work through. Okay, so these are sort of my recommendations of how I have seen it work well to teach coding as we level through TK to 2. So I tried lots of different activities. Some were better for certain ages than others, and then we've seen kids sort of progress a certain way. And so this is just my experience, what I recommend you sort of start with. Level 1, you can kind of think of as TK. This is usually what we focus on in our TK lab. But also, your TK kids might go past this and then feel free to move into level 2. Or you might be teaching a first grade class that has never done any coding, and you want to start with first grade down here at level 1 and see how they can move through. But that being said, I always recommend starting with some unplugged activities. So, talking about what is coding, what is a robot. What is a computer? To talk about the hardware versus the software. They use a mouse, they use a keyboard, or maybe it's a touch screen. What does that mean? Also, you definitely want to educate kids on how to safely use a computer or a tablet. So we don't want to toss it around. Um, and then also working on some of those unplugged activities that I showed in the beginning, like building a robot with shapes and doing movement, hopscotch, dances, and relating that back to coding and what they're going to experience when they get into an actual robot station or a coding station. Doing some of those unplugged offline activities to help them wrap their brain around what does this mean, as how does this connect to other pieces of my world. And then you can move into really just focusing on input output. So with our TK kids, that's our goal is that they understand that what they're doing has an effect on the robot. So they're instructing this other machine, this other creature, on how to operate, and that they have to be very specific with their input to get the output that they want. And so in this video, this was one of our TK pilots, and this was my very first day with them, and it was really just play. So play with this robot. Let's talk about how it works. What do they notice? What works? What doesn't? And you'll see in the video, it's a little chaotic. They're trying to figure out how to tell a story with this robot and how to use the pen, how to use the cards. This one also has a joystick. So they're just playing and figuring it out.
Get a burger first, and then when you get the money back, you could give it to me. Are you kidding me? Just say it.
So it's a little chaotic at first, but it makes for some great conversations. The kids start to help each other out, and they start to figure out that their actions have an effect. After they've really mastered that input-output process, you can move into making some predictions and building a sequence. So how do we want to get this robot to the corn card? How are we going to set up our steps in a sequence that might be successful? And then also, when it's not successful, how do we problem solve bugs in the code? And so in this video, this is another one where we're trying to get this, I think this one was a puppy, to its bone. And what do we have to do? What are the steps we have to take to get there? And this was the same class, but this was, I think, day 3. So I had seen them for a little bit of time. They were understanding how to use the coding cards, how to use the input and output. But now we're working on building a sequence based on what they think they need to do.
All right, how are we gonna get him to the meat? Well, how can we turn him with the cards? Yay!
And so my next level with these kids, after we've done this activity several times in different ways where they're building successful sequences, I like to set up a sequence for them that has what we call a bug in the software in the algorithm, and see what they do when they get to that bug, and then eventually see if they can spot the bug or the problem with the code before we even run the code, which is probably more of a level 3 thing. But once they've accomplished getting that sequencing down, we want to start to put in some problems for them to solve. Okay, level 3. Many of the robots, but not all of them, come with this thing called a starter flag. And so at this point, their student would create the sequence ahead of time, and they basically input all of the sequence, and then they're able to hit this flag to hit go. So in the previous videos, you saw they were going one step at a time. Really, for TK and Kinder, that's a great level to work at. They don't really need to use the starter flag, but we've had some situations where kids were able to make a pretty complex line of code. And so instead of doing one card at a time, it's interesting to start them putting in all of their code and then hitting the flag and letting the whole thing run. That also helps when you get to that problem solving for the bug, to have them set up the entire code, see if they can spot it before they run it, see if they can troubleshoot and double check their code before it runs, and identify any problematic things, or have the robot run and then see where in that line of code did something go wrong. So that's a much more abstract way of thinking. So that's usually more of a first grade level thing, unless you have done this a lot of times and your TK and kinders are ready for it. Some robots also come with these conditional statements, which is very common in coding, where if something happens, then it triggers a different event. It's much more complex. So with TK and Kinder, I've never gotten to this point, but perhaps in first grade and definitely in second grade, because this is definitely in all of the screen-based coding. Like if they hear a clap, then a light would go on, like for the Kibo robot. Or if they hit a wall, then they turn right. So having those conditional statements is a much higher order thinking coding skill, but that's something you can level up to. And then also incorporating multipliers. So in some of those other videos, we had like 2 or 3 straight cards, straight forward arrow cards that the kids were tapping each individual one. As they get better with their math, with their numbers, you can minimize that and have one straight arrow times 2, or 3 turns, or 5 turns, and just have them spinning around. But you can start to sort of level up their ability to make their code much more efficient by using some of these multipliers. But obviously, that might not be a skill that TKs have if they're just identifying numbers. So use that as you will, but that's another leveled up skill. And then finally, I would really wait to get through a lot of that stuff with robotics, with a physical world first, before you move into screen-based coding. Scratch Junior does market itself like K through 2, I think, or K through 3. So it's absolutely accessible for kinders, but I just find that the robots are just such a better way to teach coding because they're seeing it interact in their physical space. And then once they have some of those skills down, then they can practice in Scratch Junior. Also, Scratch Junior has a lot of different options, which could be overwhelming for some kids if they haven't already experienced and mastered some coding already. So you can definitely use it with your kinders, but just be aware that it's very open-ended. There's a lot of different options. And so you'll really need to guide your students through that. Whereas if you've done a lot of these things already, they might be better prepared to do some screen coding. There are also robots that can be programmed with block code, so you don't have to completely ditch the robot when you get into the screen-based coding. There are some robots where you can do some screen-based coding, plug in your robot, and then transmit the code to the robot, and now you get to see the robot still act out that coding in a physical space, which is a great transition. So Kibo will do that. They're working on that, I think, to be released next year. And also, there's a robot called Cody Rocky that's sort of a step up from the M Tiny, so it looks very similar, but you are able to work with Blockly in there, so they would be able to screen code and then transmit it to the robot. Okay, strategies. How do you do any of this? So you understand what to teach, but like, how do you do it? Again, I always say start unplugged and start just letting them play. Even once I'm teaching skills, I'm sort of gradually introducing some complexity and then giving them time to just play. And so they may master that skill right away. They may struggle with that skill. They may just play with the robot. But all of it is a learning experience because that play-based learning is so important. I also really encourage just giving them time to explore with the robot. So if you have a PlayStation, put the robot in there one day and don't have any goals for it perhaps, but just let them play, let them explore. Maybe they'll learn some different skills while they're just playing with it. Um, but also while I'm explicitly teaching some skills, I want to allow some time for play and practice after that. I do recommend, especially in K and TK and K, to have that be the adult supervised station, have an adult around to sort of monitor, if only for the sharing aspect. So typically you don't have a robot for every single student. That's very rare. I've never seen it. So you're probably working in groups of 3 to 4 to a robot at least, if not more. And so the sharing part gets tricky, probably trickier than them actually understanding the code, and also to provide support when they start struggling with the coding part so they don't just give up. You can just help give some reinforcing statements and questions and be there to help guide them through that. So definitely at those two levels, you want it to be adult supervised. By first, they may know enough to kind of do it on their own, maybe even a kinder class if they've done this for a while. But I would recommend that always being your adult supervised station, just to provide that support. As far as ratios, really 4 to 1 is the max that I would go. 2 to 1 is ideal, but obviously not doable all the time, depending how many kids you have. But past 4 students, you get a lot of kids, that fifth, sixth student, just being bored, waiting for their turn with the robot. So 2 to 3 is great. 4 could work, but more than 4 it gets more difficult. And then also just recall those child development stages. So in our early ed um, classrooms, they're really working at that pre-operational stage where they're just kind of identifying things. Their logic is just starting to develop. So try not to push them too far into an uncomfortable zone that their brain just isn't ready for, isn't developmentally ready for. And also, recognize that you may have students that are ready for that. And so just lean back on your child development classes and kind of recall where they should be, just like you do when you're teaching reading and writing and those sorts of things. Okay, couple models that I've used and just some pros and cons. So in my lab, I do sort of a whole group modeling, and then we're actually really lucky to be able to have like 5 to 6 stations of kids doing robots all at one time. This requires the most robots of any of these models. So I have 6 robots that I use, and I'm also really lucky that I typically have chaperones or teachers there with me and a co-teacher that there can be an adult at pretty much every station, if not like maybe one adult per 2 stations. So we can monitor 6 to 8 kids at a time and be there to provide that support. But I'm completely aware that this is not doable for many classrooms. But if you happen to be maybe a lab teacher or a librarian that is picking this piece up, maybe that is something that you can do. So we do some explicit teacher modeling and instruction, and then this really does allow a lot more time for the kids to play around with it because we can have all these groups going at once. So that's one model. Another one that I did in my pilot that seems to work better in the classroom setting where you have less robots available, less adult staff available, is having the robots having like a robot day. And so you could have different stations going on that have to do with robotics, but only having 1 or 2 actual robot stations. And so, in one situation, we had some unplugged coding and engineering activities happening. So the kids doing like the building of the robot with shapes and patterns, maybe like a little sort of dance thing going on or something, some kind of unplugged coding. And then one station was robot free play. And then one station was an actual coding activity that was led by an adult. This is great if you only have like one day to do some coding, or if this isn't like something you're doing over time. It's less robots. You only need maybe like two or four, 2 to 4. It's also great to engage multiple learning styles because you can do like a robot hour, but they're getting a little piece, a little taste of robotics in different ways, and coding in different ways throughout their day. So some pros and cons in that one. But this is probably the one I've seen most successful for most classroom teachers is where this you have one robot station that is just your single robot station in the midst of all your other stations that you typically do. But the key is that it's consistent. So every single Friday when you do stations, you have a robot station. Or perhaps every single day when you do stations, you have some component of robotics or coding that's part of those stations. This is also great because it treats coding like any other skill. You have a math station, a reading station, a coloring station, or an art station, and you have your robot station. Whatever stations you typically do, just being able to insert the robot in there and have that be maybe your adult-led piece that day, or maybe it's just the robot play that day while you're doing the math or the reading station. But having just the robot around or some kind of coding component in every station that you do, having that be every center activity that you do, having that be one station is great because it just reinforces that skill over time. And you'll see those kids make a lot more leaps in coding because they get that 15 minutes a week or 15 minutes twice a week to be able to experience that coding. It also requires the least amount of robots. You can totally do this with just one classroom robot because it's just going to be one station of many that you're doing over time. So a couple different models that you can consider if you're looking to incorporate robotics in your classroom. Okay, so the last couple slides, I'm just going to leave you with some resources. This slide has a bunch of unplugged resources. The Codable Elementary Guide is amazing. There's a lot of unplugged activities that you can do, grouped by different modalities. So whether it's dance, whether it's art, there's a whole bunch of great activities that you could do. That could be your unplugged station. Code.org also has different courses, whether you're kinder, first, or second grade. And the kinder ones could be doable in TK too. They're not that complex. And then we also have hour of code activities that are unplugged. If you're looking to screen code, I'd highly recommend looking into coding as another language. It's just a great approach to coding that I haven't seen before. And they have a very robust curriculum with all the pedagogy behind it, all the teacher moves, the science behind it. And they also have a ton of unplugged activities too. So I probably also should have included that link on that first slide. Most of the TK curriculum for Cal is unplugged, with maybe some Scratch Junior in there. But a lot of the TK and the K activities for coding as another language are unplugged. And then Scratch Junior, of course, has its own curriculum when you're looking to screen code. And then code.org uses just Scratch, so it's not as junior friendly, but it may be appropriate for your first or second graders that have already seen Scratch Junior and are ready for more complex activities. And then for robotics, I've included the mTiny and the Kibo curriculum because they both have their own curriculum free out on the internet if and um, could be used with other robots too. A lot of those activities are they say are device specific, but they're not. You could do a lot of Bbot activities, a lot of mTiny activities with the Bbot or with other robots. And then Bbot has a whole bunch of floor map activities. Same thing. It's geared toward Bbot, but it could totally be used for any other robot that you have. And then Kibo has some great ideas for student created floor map activities because Kibo is probably the one robot that does not come with floor maps because they really encourage you to have your students involved in creating the maps, making maps very specific for whatever you're doing in your classroom with other topics. So they have some ideas for activities there and how to build floor maps. Also, not completely coding and robotics related, but I wanted to put a plug in there for Common Sense Media's digital citizenship lessons that are new for TK to 2, that really focus on healthy habits with technology and being safe online, and also a little bit about cybersecurity as far as like passwords and things like that, which I think is great that they're recognizing that even our youngest learners are using technology and they do need to learn a little bit about digital citizenship. If not using technology like passwords and things, cybersecurity, the healthy habits is just a great way to introduce how do we balance how fun technology is with also the need to like take a break from technology sometimes. Okay, and so I want to end with my challenge to you. December 9th through 15th is Computer Science Education Week, and the month of December is like Hour of Code Challenge month. So if you've never done coding, or if maybe it's been a while, or maybe you're looking at different ways to do coding, you've got a little over a month to plan out how you could tackle December and do 1 hour of code with your kiddos and challenge yourself to try something new. So check out some resources there and let me know if there's any way that I can support you that week or that month. I would love to hear about and visit maybe some classrooms that are doing Hour of Code challenges. All right, so thank you very much for watching this recording. Please reach out if you have any questions or if there's any way that I can support you in your journey to code with littles. And then also, here's our link to register for our next session, which will be in December, and we'll be discussing storytime design thinking. Thank you.